When you hear the word directed line segment, what jumps out at you? It's a line, but specifically a segment. What does directed mean typically? It's okay. Is there a part of the word directed that stands out to you? Direct. So this has direction. That's basically what it's saying. So the order, if you had to take a guess, would be doesn't matter or doesn't matter. Does it or doesn't it? Yes, it matters. No, it doesn't. Yes, it does. Yeah, so before the order did not matter. For directed line segments, we're specifically going from one point to the other. So again, recall that the slope of a straight line is graphed on the coordinate plane, and it has a ratio of rise to run. That's your slope. So what would be our rise for the segment AB? I go up how many? 1, 2, 3, 4. I rise 4. We might reduce it though. Is that what you did? You reduced it by 4 and got 1. What's your run? 8. Yeah, I think that's what you did. So we would write it as 4 over 8 and then reducing it to 1/2. So that's your slope. Your rise is essentially the change in y, which is y2 minus y1. And then your run, again, this one did matter. Whenever you find slope, your subtraction, whatever you start with, has to be what you start with. So if I started with y2, I have to start with x2 when you're calculating your run. Have you guys seen the triangle to mean change before? Delta, yeah. So this is delta. Delta, it means change. It was hit or miss. I used this in another class and they said they've never seen it before, ever. You use it in physics. Nice. It's been a minute since I've been in physics. So a directed line segment is it's a segment that has direction. That's it. Order matters. Always. Does matters have 2 T's? Yes. Yes. Okay. Yeah. I was looking at that. That did not look correct. So we're going to write our steps, but the first part that we're going to do, that's going to bother me. The first step that we're going to do is we're going to go through a problem and we're going to work out it together. So example 1 is what we're going to talk about. We have A at 3, 4 and B at 6, 10, and point P on the directed line segment AB such that it partitions the segment into a ratio of 3 to 2. So visualizing this, you can graph it. I'm going to make a number line or just make a segment like this where I have A here at 3, 4. And I'm going towards B, point B. And B is at 6, 10. And this is going to help me visualize it. If P is along the line segment from A to B, so that means this is point 1 and this is point 2. So I'm going from 1 to 2. If P is there such that it divides it into a ratio of 3 to 2, that's my important ratio. It's 3 to 2. Where should P be located in between A and B? So that's what our question is. So find point P. Just to visualize this, is P going to be closer to A or closer to B? It's dividing it into a ratio of 3 to 2. So there's going to be more space on the A to P point. So you want to put your point like right here where this is 3 and this is 2. That's what we're doing. So point P is there. This section is going to be a ratio of 3, and this section is going to be a ratio of 2. So, like, do you guys know do you recall what ratios are? Like, we can do a ratio of genders in this class and count how many girls and how many boys and all that stuff. And then we would reduce the ratio. So, like, there could be 15, let's do cats and dogs. We could have 15 cats and 10 dogs in this classroom. That's a lot of cats and dogs. I don't know how we would survive. I think all the cats would be hissing and all the dogs would be barking, whatever. 15 to 10. 15 cats to 10 dogs. You could reduce that and have it be what? 3 to 2. So I'm not telling you that this is the length. I'm telling you this is the ratio. That's what that is. I'm going to change this ratio. This is the first step. Change the ratio to a percent or a fraction. So change ratio to, I call it a percent because it ends up being like a decimal. So change ratio to percent. And to do that, your ratio is typically given A to B. And so we would change that to be 3 out of how many? How would I write this as a percent of the way or a fraction of the way? You would take the part that you're trying to divide it by, which is what? 3 over how total it is. 5. So you would do, how did we get 5? Add the two denominator, or add the two parts. So we would do, I like to call it part over whole, but it's really just A over A plus B. That's the formula version of it. If you feel like you need a formula, it does get a little bit messy. I don't like dealing with formulas if we don't have to. So, cool. You told me what the answer was. So the ratio is 3 to 2. The percent is 3 over, remind me? 3/5. So we are going 3/5 of the way. We're using rise and run to figure out where that is. So if I were to graph these points, go ahead and do that. 3, 4 is A, and B is 6, 10. So I think the big tick is 5, 6, 10 is right there. That'll help you graph it pretty quickly. We're going to take the percentage of the run and the percentage of the rise, and that should get us our point. So the percentage of the run, let's go ahead and find out what the run would be and multiply it. Oops, I went too far. There, I made my triangle. So let's go ahead and do it mathematically, and then we'll go back to our diagram so we can visualize it. So I like to do the run first because that's how we're writing our problem. We write it as x comma y. Again, x2 minus x1. So what would that be? Yep, 6 minus 3, and that gets us 3. So we are going 3/5 of the way. 3/5 of the way of 3. And then we're going to end up adding it back to our original point. So let's multiply 3 by 3/5. We're doing a couple steps at once. We're taking 3 and we're multiplying it by 3/5. Yep, calculator will help us for this. If you do it, what's 3 times 3? 9 divided by 5. Yeah, you will get a decimal, but a nice decimal. 9 divided by 5, I get 1.8. That's the total run that I actually go. I don't go 3 because 3 would be 100% of the way. I go 3/5 of the way, which is ending up being 1.8. So if I look at that, that's going to be like estimating about there. So I'm going to actually add that. That's going to be your x coordinate. So to do it mathematically, you're going to add back your original x, which in this case was what number? We're taking 1.8 and we're adding back how much? This part right here, which is 3. Yep. Add back x1, so you're going to add 3. So your x coordinate for your point is 4.8. That's your x of your p, which is the partition point. I'm halfway done. I'm halfway done. The next part I would like you to talk me through, and I know that you just saw this and it's not the easiest thing in the world, so you are allowed to take guesses and see what happens. This was for the x. You're going to do the same exact thing for the y. So what do I do? Beautiful. Y2 minus y1. Again, it's okay if this is not too clear. We're doing, instead of the run, we're doing the rise now. 10 minus 4 gets us 6. Okay, so now we're at the same point where we found the run, and now we want to do what? Times 3/5, the percent. This is the percent. I get 18. 3 times 6 is 18 divided by 5. Yeah. Yep, 3.6 is what I got. So that is my total way that I'm going, and I'm adding it to my original point. So I'm going to go up 3.6. I think that's like right there, and hopefully I end up at the same point. I mapped it out on my graph to see if that looks right. So my original point or my new point is not 3.6, but it's actually going to be, what do I have to add back to it? This was adding back my x1. So we have to add back our y1, which is, no, not 6, 4. So we get 7.6. And that does look about right. So writing your final answer, P as a point, so we would write 4.8, comma, 7.6. What do you guys think? Like almost fun, right? It was almost like we needed to calm down with how much fun we were having. No? Okay. Yes, Gabby. Yes, the x1 and the y1. So right here, we're taking, right here, this part. Okay, so what you're doing is you're finding how much you change. We're finding this value, and then we're adding it back to my original x. And so in order to do that, we have to add back however many points your x is in and how many points your y is in. So we can't just start at 0, 0. We have to add back. We're starting with point A or 0.34. We have to add to that point. We are going 1.8 units, and we are running that far, and we are rising 3.6. So that's why we always add back our original x and our original y. Yeah, of course. Let's write down these steps so that we can reference them later. So the first thing we wrote out was to change the ratio to a percent. The next thing we did was what? It was the very first thing that we wrote down, which was We found the run and the rise, right? Yeah. Okay. Find run and rise. So we did that. Our x2 minus x1, y2 minus y1. The next step, yep, multiply by the percent. And then step 4, add back what? X1 and Y1. And the last step for good measure, write as ordered pair, which is just X comma Y. I do not like graphing it personally, just because it doesn't help me as much as seeing it as like a horizontal number line. And I just draw it out just so that I can visually see where my where my fraction is, what the fraction of the way is. If it's already written as a fraction, you do not need to change it. For the next example, I have A at 1, 1, B at 7, 3. We want to find point P on AB such that it partitions the segment into a ratio of 1 to 4. You always assume that your first point is your first point, and our second point is always our second point. So, you guys want to talk me through it? Sure. What should I do very first? 1 divided by 4. I'm going to make a line. Yeah, so A, B, where should P be? Yeah, I agree with that. P should be closer to the A, and then what number would be between A and P? 1. And then what number should be here? 4. Okay, so my A to B is 1 to 4. So A is 1, B is 4. What should my percent be? 1/5, yeah. Remember that you are doing the whole thing. The whole thing is 5. We get that by adding the two parts. Again, that's only if it's written as a ratio. It tells you this is the ratio. You would write it as 1 over the whole length, because we are not going 1/4 of the way. We're going 1/5 of the way. 1 out of 5. That's like one of the things we need to really be careful about remembering. Okay. Now that I have the ratio changed to a percent and I drew it out just for good measure, what should I do next? Find the run. Okay. What should I subtract? 7 minus 1. 6. Yep, I like how we did the second point first. That is very good. And what should I do next? Sure, I can do that. 1/5. That gets me 6 over 5. What's 6 divided by? Oh, I think I know that. What's 6 divided by 5? Because I think fifths go by 0.2. So I think that would, yep, it is 1.2. Verifying your calculator if you need to. So instead of going 6, I'm going 1.2. So we have to add back what? X1. So we're going to add back not 7, but 1. So that gets me 2.2. That's my X coordinate. So I can start writing my final answer as 2.2 comma whatever my Y coordinate is. Yes, JJ. We added back So when we are moving, it's in between A and B. So A is at 1, 1, and B is at 7, 3. So I know this point P is 1.2 away from 1. So really, we're adding 1.2 to 1. But because we can't do that, we're going to add 1 first. Are you okay? Okay. Like, oh no. If you need to get water, go get water. I completely understand. Is that okay, JJ? Did I explain it, or are you not quite? Okay, so you're always going to add whatever this point is. So we're going to take, really, it's like we're adding 1.2 to 1. Remember when we did the endpoint midpoint problem where we were adding it again? That's this. We are just adding it again. So A is here, P is here, and B is here. A is at 1, 1. We need to add to the x's, we need to add 1.2. And then we're going to figure out what we add to the y's. So P is going to be 2.2. Okay. Someone talk me through how to do the rise, the y. Go ahead, Isabel. Mm-hmm. Mm-hmm. Yeah, I agree with that. So that's 2/5, which is just 0.4. And then again, you're going to add that to the 1. So I'm just going to add my y1, which is right here. Which gets me 1.4. 1.4. So that's my partition point, 1.4. Okie dokie, maybe, question mark? Yes, JJ. Yes, the reason why we wouldn't add to the B is because then we would be extending our line. So we know that 1, 1 is here and 7, 3, I think is right there. So we know that we have to add to my first point going from A to B, because otherwise we would be extending our line like right here. And we're just making an extension. So remember how lines, they keep going infinitely? These are segments. So this is just a part of a line. Okay. I'm going to let you guys have the rest of class to practice. I am checking 2 questions in particular, and even an odd question. And I will tell you those numbers at the end of class. But go ahead and start example 3. I want you to try first before we go over it. It tells us a percent already. That's the only difference between example 3. So go ahead and take a moment to do that one in your groups. You don't have to do step 1 because step 1 is already done for you.